Welcome to Mrs. Bibb's Algebra 2 class, weeks 17, 18, and 19. Today we'll be learning how to use the skill of completing the square to rewrite a quadratic in Vertex form. We will also be reviewing how to solve quadratics using different methods. Please make sure to fill in your table of contents and do your weekly warm-up. You're going to need Student Journal, page 59 first. We're going to solve these quadratics using any method that we would like to use. You could use factoring, you could use square roots, you could complete the square. Whatever method that you prefer, that's what you could use to solve. When it says to explain your reasoning, you do not have to do a physical explanation. Just think about why you chose to do the problem that way, and then be ready to share that experience if asked. When I look at number 14, I could solve that using completing the square because I have a quadratic term and a linear term, and then I don't have a constant term besides 0, so I could complete the square. But for me, when I look at that, the easiest way to solve that quadratic is to solve by factoring. I see that x squared and 7x have a common factor. So I'm going to remove the x. X squared divided by x is x. 7x divided by x is 7. Now I'm ready to do the zero product property. You set each factor equal to 0 and solve. This first factor is solved, x equals 0. The second one, x would equal -7. So my two solutions for number 14 are -7 and 0. And please remember, if you see any mistakes that I make, and watch out for them because I do make silly mistakes, just let me know. Be kind, but just let me know that I've made a silly mistake, and I'm happy to own up to it and to correct it when need be. Looking at number 15, when I look at that problem, the only method that I see that I would like to use is the square root method, because I see that I could take the square root of both sides, and I would get x minus 1 on the left side equals plus or minus the square root of 35. 35, the factors are 1 times 35 and 5 times 7. None of those besides 1 is a perfect square, so plus or minus the square root of 35 is as simple as it gets. And then I'm going to get my x alone by adding 1. So x will equal 1 plus or minus the square root of 35. And I'm just going to leave that in that form there. Please remember that you do have two solutions, one plus the square root of 35 and one minus the square root of 35. For number 16, when I look at it, I see two ways that I could solve, and it does not matter to me which way you choose. When the directions tell you to choose, the way, or if it doesn't ask you to do it a certain way, then you choose what way you see first. And honestly, the way it's written, to me, it's ready to be factored. I have a difference of squares. One thing I've noticed while we've been doing in-person learning is that students have not gotten themselves into the habit of seeing the difference of squares and putting two empty binomials, one with an addition sign, one with a subtraction sign, and of course I'm going to keep my equal 0. Then I take the square root of x squared, and I do expect to see that. The square root of x squared is x, and that goes in the first spot of each of these. And I take the square root of 225, which is 15, and that goes in the second spot. Now, I have a factored form of x squared minus 225. I'm going to do the zero product property. I'm going to set each factor equal to 0 and solve. When I solve the first one, I get negative 15. When I solve the second one, I get positive 15. My two solutions are negative 15 and positive 15. And honestly, whatever way you want to write that answer is fine. 17. Since I haven't solved by completing the square, I believe I'll solve this one by completing the square. For 17, the first thing that I see that I should do to complete the square is that my a value is not 1. So I'm going to divide the entire problem by 4 to make my a value 1. That would leave me with x squared plus 2x plus 3 equals 0. And honestly, as I look at this, I see that it's easiest to factor. But I think it's really good for you all to experience completing the square. If you would like to solve by factoring and see if we get the same answer, that's perfectly fine. But I do want to just go through completing the square with us. So to complete the square, I need to move this c value to the other side. I'm going to have x squared plus 2x. I believe in that other video I told you to leave yourself a space, equals negative 3. Next thing I'm going to do is I am going to take that b value, my new constant that I'm going to need is taking the b value of 2 divided by 2. And 2 divided by 2 does give me an integer answer, so I'm going to put that integer answer. Then you square that, and then you add that to both sides. Now, the next step is to, oops, I didn't add it here, did I? The next step is to factor the left side. So the left side factors into a binomial squared. Remember, when completing the square, you are creating a perfect square trinomial that factors into a binomial squared. It always works this way, that you use your middle variable x, or whatever that middle variable is. The answer, when you divide it by 2, is what goes beside of that x. And then you need to simplify on the right side. Negative 3 plus 1 is negative 2. And I take that back. That will not factor. See, I mentally make mistakes all the time. That will not factor. Now let me tell you how I knew when I looked at this problem that it will not factor. I knew because at this point in the problem, I'm going to take the square root of both sides. And I know that the square root of a negative, and I know that you know as well, the square root of a negative gives me a complex number, or the imaginary unit I. So that means it will not factor. Okay, so I'm going to square root both sides. Square root of negative 1 times the square root of 2 plus or minus I times the square root of 2. I'm going to subtract 1 from both sides. So x is going to equal negative 1 plus or minus I times the square root of 2. In a problem that will factor, you would never get an I for an answer. So that's how I knew at this point that this would not factor. Okay, we'll try number 18 next. I'm glad to see a problem like number 18 on these notes, as oftentimes this is the way this skill is tested on a standardized test. It would give you a figure and ask you to find the value of x. And of course it gives us the area. So the first thing we need to know is that the area formula for a triangle is 1/2 times base times height. We're going to fill in what we know. The area is 30. Keep your 1/2. the base is x plus 2. The height is 3x. To be honest with you, the first thing that I would do is get rid of that fraction, not by distributing it to the x plus 2. I would actually multiply both sides by 2 first, just to get rid of that fraction. And I know many of you would agree. Now, when I multiply the right side by 2, I can cancel out the 1/2. 1/2 times 2 is 1. And then I'm going to multiply the left side by 2, and that would give me 60. 60 is going to equal, and I'm going to go ahead and multiply these inside of those parentheses that I've created, the red ones on the right side. So I'm going to have 3x squared plus 6x. Now I want to factor this, because right now that's the only way I see that's the best way. So I'm going to subtract 60 from both sides to make it equal 0. I do see that I have a common factor. Since I'm solving, I'm going to divide away that common factor. Please, please, please remember you cannot divide it away and lose it and forget about it when you're just factoring, when the instructions say factor. So I'm going to have x squared plus 2x minus 20. Now, will that factor? Can I find factors of negative 20 that will give me a sum of positive 2? I know one of those has to be negative, but I'm just thinking for a moment. No, I cannot. So I'm going to have to complete the square, I believe. I hope I have enough space. To complete the square, I'm going to add the 20 to the other side. But I'm also going to use the symmetric property of equality and go ahead and put x squared plus 2x on the left. I'm going to leave a space, put equals, and put positive 20 on the right. So I hope that's okay with you guys, and you can see that I just used the symmetric property of equality to flip that around. Now I'm going to take my 2 and divide it by 2. Remember, I'm finding a constant c that I'm going to add to both sides to make the left side a perfect square trinomial. 2 divided by 2 is 1, and I think we just did exactly this. 1 squared is 1, so I'm going to add 1 to both sides. Next, and I think I'll just go over here to the right. Next, I'm going to factor the left side. It factors into a binomial squared. Use the middle variable. Use what's in the parentheses, the answer you got when you divide it by 2. And it's going to equal 21 because you simplify on the right. Take the square root of both sides. X plus 1 is going to equal plus or minus the square root of 21. Then I'm going to subtract 1 from both sides. So x is going to equal negative 1 plus or minus the square root of 21. Now I would leave it this way. And actually, no, I wouldn't. I'm going to go over here on the far left and see which one of those I need to toss out, because both of these sides need to be a positive number. If either of those give me a negative number, then I've got to toss it out. So I'm going to put x equals negative 1 plus the square root of 21. I think they'll both give me a positive, but no, they won't. And then x equals negative 1 minus the square root of 21. Can you see that the second one that I just wrote down would give me a negative answer? And if I substituted that negative answer in for x, then this one would not be possible. My only solution for x is x equals negative 1 plus the square root of 21. If you want to find a decimal for that, that's perfectly fine. You do not, but that would be the only answer for that problem. Okay, so moving on to the next lesson, and I may actually have to break this up into 2 different videos I have typed the steps that you would use on the right-hand side. And some of that may be just a little bit different than what we had written down in the classroom, but that's okay. Keep what you have. I will try to make sure to do these in the same order in which we did them in the classroom, but I might forget, so forgive me. Just watch the video if you will, please, and do the ones that we have not done yet. Number 19, I do believe, is the one that we started with. Y equals x squared plus 4x. As the steps say over there, we group the quadratic and linear term together. Next, we check to make sure the a value, or the coefficient of the quadratic term, is 1. It is. So the next thing that we did was create a constant, or a c value, by taking the linear coefficient, or the b value, and dividing it by 2. That answer is 2. Square 2, get 4, and we added 4 inside the parentheses next. So y will equal x squared plus 4x plus 4. The next thing that we did was check this outside coefficient, if we have one, and this one. We didn't necessarily check them, but we multiplied these two. 1 times 4 in this case. So 1 times 4 is 4. So we need to balance out this equation by, if we added 4, we need to subtract 4 to make sure that it's a balanced equation. And so y will equal, I apologize for all those bells, y will equal x plus 2 squared minus 4. We factored and we simplified. Now let me talk about that factoring again. Remember, when you complete the square, or use that process of completing the square, you use your middle variable, and then you always use the answer that you got when you divided by 2 with that middle variable. So that's how you get that factored. And this is my answer in Vertex form. That's all I have to find. I think the next question I ask the students is, one of those, 19 through 30, one of them really does not belong. It is really already in Vertex form. And I ask the students to think about it for a little while. So if you'll look at them for a minute and think about it. And hopefully you see it's number 25. Number 25 is already in Vertex form, so we will not be doing number 25 at all. The next one that we're going to do is number 24. So we'll do 24 next. Y equals x squared plus 5x. And I can go ahead and group it here if you'd like. Since you don't have these problems above there, you may want to write the original and then group, just so you'll have that whole process, the whole flow there on your paper when you may need to look back at completing the square. Okay, now I am going to take my b value of 5 and divide it by 2. And that's, I'm creating my c that makes this a perfect square trinomial. 5 will not divide by 2 evenly, so I'll just go ahead and square this and get 25/4. And then I'm going to add 25/4 inside the parentheses. So y equals the quantity x squared plus 5x plus 25/4. Then I'm going to multiply the number that's out here. I forgot to say I'm checking that coefficient. My coefficient was 1, so I'm okay. But I'm going to multiply the number that's out here by this number. 1 times 25/4 is 25/4. And then to balance that out, if I've added 25/4, I need to subtract 25/4 to balance that out. And now I'm going to factor what's in the parentheses. Remember, it always factors into a binomial squared. Use the middle variable x, and then always use the answer you got when you divided by 2 with your variable. So x plus, it's a positive, so I put plus, x plus 5/2, and then minus 25/4. Okay, so now we've done 19 and 24. I'm thinking, I don't remember which one we did next, but I'm going to do 21 next, I do believe. So for number 21, y equals, I'm going to go ahead and group them together. You may want to write down the problem. So y equals negative 2x squared minus 8x. I don't always say the step of checking that quadratic coefficient or checking your a value, but as I look at this a value, it's not 1. So I need to divide by negative 2. Put that negative 2 on the outside. You can't lose it. You have to keep it because it tells me two things. I've got a reflection across the x-axis and a vertical stretch of 2 from the parent function. So that would be positive x squared plus 4x in the parentheses. Now find your c value. C is going to be b divided by 2, which is 2. Square that, which is 4. And add that 4 into the parentheses. So y equals negative 2 times x squared plus 4x plus 4. Next thing I should do is multiply the number outside by what I added in the parentheses. Negative 2 times 4 is negative 8. So I've really subtracted 8. Now what do I do to balance this out? Then I would add 8 to balance that equation. So y would equal negative 2 times the quantity x plus 2 squared plus 8. Okay. So I've done 19. I'm not going to do 25. I've done 24 and now 21. Let's do number 20 next. Y equals 2x squared plus 8x grouped together plus 3. Check my quadratic coefficient. A is not 1, so I make it 1. Keep that value of 2, so I'd have x squared plus 4x plus 3. Find your constant you're going to add inside the parentheses. So that c value is b divided by 2, which is 2. Square it. You get 4. Add 4 inside the parentheses. So y equals 2 times the quantity x squared plus 4x plus 4 plus 3. Next, I'm going to multiply the number outside with the number that I just added inside. Don't forget that step, it's so very important. So 2 times 4 is 8. I added 8, so I'm going to subtract 8. Y is going to equal 2 times the quantity x plus 2 squared minus 5. I factored and I simplified. So the vertex is negative 2, negative 5. Now, I think I'll do 22 next. And I apologize for skipping all over the place. 22, y equals negative x squared plus 4x plus 4. Group the first two together, the quadratic and linear term. divide by -1. So that means I'm going to put a negative on the outside. And I'd have positive x squared minus 4x. And you can do what I just did. You can leave that space if you'd like. Then find the constant that you're going to put in there. The constant would be -4 divided by 2. It's -2, square that, you get 4. So you add 4 inside there. Next, I am going to multiply the number outside with the number that I just added on the inside. And that's going to be -1 times 4, which is -4. So I've technically subtracted 4, so I'm going to add 4 to keep it balanced. Y will equal negative, factor the trinomial, x minus 2 squared, and simplify on the outside, plus 8. I apologize for that little tail on my subtraction sign. I think I can get rid of it. Oops, I got rid of a lot more than what I wanted to. Okay, so we did 22. I think I'll do 23, 26, 27, and 29. Moving on with number 23, we are going to group the quadratic and linear term together. We're going to find that new constant c that would make this a perfect square trinomial. Take your b value or your linear coefficient, divide by 2. That gives me -2 squared. That gives me 4. I'm going to add 4 inside of the parentheses. I'm going to multiply the number outside, and I don't have one, but remember to always consider that number that's outside, if there is one, with the number I just added in the parentheses. So I really just added 4 in the parentheses. So to balance it, I subtract 4. And then y equals x minus 2, that quantity squared, minus 8. And they're testing the fire alarm, so no worries that I'm not being safe and leaving the building. Okay, 26, and I think we started this number much earlier in the lesson in second period, but that's okay. We'll just do it now for all of us. I'm going to group the quadratic and linear term together. My a value, or my quadratic coefficient, is not 1, so I'm going to divide both of these terms by -3 to make it 1. So y will equal -3 times the quantity x squared plus -1x divided by -3 is positive 1/3 x. Next, I am going to take and find my new c value. So I'm going to take 1/3, divide it by 2. And what's the same thing as dividing by 2? Because this is what we really need to know when we're working with fractions. The same thing as dividing by 2 is multiplying by 1/2. So 1/3 times 1/2 is what I'm going to do. So 1/3 times 1/2 is going to be 1/6. I'm going to square that answer, which would be 1/36. And I'm going to add 1/36 inside the parentheses. Then remember, I need to multiply the number on the outside with the number I just added in the parentheses. I'm going to take that up here so I can show you what to do. I'm going to do -3 times 1/36, which some of you may need to see it like this. -3 over 1 times 1/36 would be -3, -3 times 1, numerator times numerator, divided by denominator times denominator. So I would get -1/12. -3/36 reduces to -1/12. So technically, I subtracted 1/12. So to balance it, I add 1/12. Y is going to equal -3 times the quantity x plus 1/6 squared. Remember, I got that 1/6 from here. The answer that you get when you divide by 2, and of course, dividing by 2 is also the same thing as multiplying by 1/2. So that's where that x plus 1/6 came from. Then I'm going to write minus 96/12 plus 1/12. Where in the world did that come from? I knew I needed to turn 8/1 into a common denominator of 12. To do that, I have to multiply by 12. 8 times 12 is 96. So now I can finish. Y is going to equal -3 times the quantity x plus 1/6 squared minus 95/12. And that would be my answer. 27, I'm going to group the quadratic and linear term together. I'm going to find that new C value. Take B divided by 2. That would give me a decimal, so I'm not going to divide it by 2. I'm going to leave it as 7/2. I'm going to square 7/2. That would be 49/4. And I'm going to add that inside the parentheses. Now I'm going to multiply the number outside. There's not one here, I realize, but just want us to be in the habit. Multiply these two numbers, and I would get positive 1/49. Sorry, I would get positive 49/4. Ooh, that was crazy. So I'm going to subtract 49/4 to make it balanced. And I'm going to factor next. So y is going to equal the quantity squared of x plus 7/2. I'm going to go ahead and put plus 4/4 minus 49/4. 1 has to have a denominator of 4, so I can put those together. So to finish, y equals x plus 7/2, that quantity squared. 4/4 minus 49/4 is -45/4. That's the answer to 27. Now for 29, I'm going to group the quadratic and linear term together. I'm going to take out or divide out the 2, take that away. So it'd be x squared plus 3x. Going to find that new C value. C is going to be b divided by 2, linear coefficient divided by 2. That would give me a decimal, so I'm going to leave it as a fraction. 3/2 squared is 9/4. I'm going to put 9/4 inside the parentheses. Y equals 2 times the quantity x squared plus 3x plus 9/4. Next, I'm going to multiply 2 times 9/4. And again, I'll take that up here so I can show that work. I just don't have the space to do it beside of me. So 2 times 9/4. So 2 over 1. That would be 18 over 4, which is 9 over 2. So technically I added 9 over 2. So I'm going to subtract 9 over 2 to balance that equation. Y will equal 2 times the quantity squared. I've got to factor that trinomial. It factors into x plus 3/2, that quantity squared. I need 10 to have a denominator of 2, so that would be 20 over 2. So y is going to equal 2 times the quantity x plus 3/2 squared plus 11/2. I did do the last two, 28 and 30, that I said I wouldn't do. I did do them. I will show them on the next slide. You may want to pause and write those down. If you do not write them down, it's okay, but it's just 2 more problems that you would have answers to that you could look at to see how to do this process. So pause and write those down if you would like. We are almost finished with these notes. I do want to go over these, and I also want us to realize when we do 20, then the other ones, I don't know the numbers. When we do those, we actually could use x equals negative b over 2a, but I saw this as an opportunity to practice the skills for rewriting a quadratic in Vertex form. And this whole entire video is actually 3 different pages of notes, so please be aware of that. As you do these, look at the page numbers in the top right corner. This is from your textbook or from your student journal, page 49. The other ones are not. So for 19, I want to rewrite that in Vertex form, and then I want to name the vertex. Okay, so my first step would be to group the quadratic and linear term together. I'm just going to keep f of x. If you want to write y, that is perfectly fine. I'm going to take that b value and divide by 2. I'm going to take the linear coefficient of 6 and divide by 2. That gives me 3. 3 squared is 9. F of x is going to equal, add that inside the parentheses, x squared plus 6x plus 9. Do multiply what's on the outside with what's on the inside. Multiplying 1 times 9, I realize that I have added 9 to complete the square. Use that process. So to balance back out, I'm going to subtract 9. I'm going to factor what's inside of the parentheses. So x squared plus 6x plus 9 factors into x plus 3, that quantity squared. It's a perfect square trinomial. And 22 minus 9, is that 13? I think it's positive 13. Then it says to identify the vertex. The vertex for this problem, I'm confident that all of you know, is negative 3, positive 13. Now moving on to number 20. A golfer hits a golf ball on the fairway with an initial velocity of 80 feet per second. The height h in feet of the golf ball, t seconds after it is hit, can be modeled by the function h of t equals negative 16t squared plus 80t plus 0.1. Now we could use x equals negative b over 2a. Remember, the maximum height would be the y-coordinate of the vertex, so we need to find the vertex. But I want to practice the skill of writing a quadratic in vertex form, and then we'll have the vertex and the axis of symmetry so that we can answer this problem or this question. So I'm just going to, over here on this side, I'm going to write h of t equals negative 16t squared plus 80t plus 0.1. H of t is going to equal, group those first two together, negative 16t squared plus 80t plus 0.1. Then I am going to divide these by negative 16. So h of t will equal negative 16 times the quantity t squared minus 5t plus 0.1. I'm going to find that new constant c. Take b, divide it by 2, square it, I get 25/4. Add that inside the parentheses. So negative 16 times t squared minus 5t plus 25/4. And then, of course, that plus 0.1 is still hanging out there. Next, I'm going to multiply the number on the outside with the constant I just added inside the parentheses. I'll go up top here and do it just like in those other videos. Negative 16 times 25/4. Now, normally I just multiply straight across. If you have a calculator, please go ahead and multiply straight across. Maybe I'll just go ahead and do that just for all of you. I would reduce, since if I didn't have a calculator in my hand handy, I would reduce the 16 and 4. And if you want to try that, go right ahead. I believe 16 times 25 is 400, and it is. So I've got negative 400 divided by 4, which is negative 100. So technically, I subtracted 100. So I add 100 to make it balanced. I'm going to have h of t equals negative 16 times the quantity t minus 5/2 squared plus 100.1. Now, I am going to write 5/2 as a decimal here because it represents the x value, or I guess in this case the t value, the time, and I need that to make real world sense. And 5/2 as seconds doesn't necessarily make sense, and we know that's 2.5 seconds. Okay, so let's name the vertex. The vertex here is 2.5, 100.1. And remember, this is your max value, has a maximum because your a value is negative. This is your max value, and this value here is where or when the max value occurs. So let's answer the questions. Find the maximum height of the golf ball. Well, the maximum height is 100.1 feet. For the next part, it says, how long does the ball take to hit the ground? Well, we've got to think about this for just a moment. The ball's on the ground. It gets hit into the air. And it takes 2.5 seconds for it to reach that maximum height of 100.1. But is the answer to letter B 2.5 seconds? after 2.5 seconds, is this ball on the ground? No, it's in the air. It's at its maximum height in the air. So, how much longer does it take before this ball is back on the ground? Here's where it would be on the ground. This is, and let me grab a red pen, this is the axis of symmetry. So if the distance from the axis of symmetry to the left is 2.5 seconds, then the distance from the axis of symmetry to the right is 2.5 seconds. So think about that for a moment. How long does it take the ball to hit the ground? And hopefully you realize it takes 5 seconds for that ball to hit the ground. The next example. The Big Brick Bakery sells more bagels when it reduces its prices, but then its profit changes. That given function models the bakery's daily profit in dollars from selling bagels, where X is the price of a bagel in dollars. The bakery wants to maximize the profit. Okay, so maximize, so that means y coordinate of your vertex. Lucky for us, this is already in vertex form. What's the vertex? 0.55. And what's the maximum? Or what's the y coordinate? 300. Now remember, this is your maximum value. The y coordinate is your maximum. I know I have a maximum because I have a negative a value or a reflection across the x-axis. And then this is where or when my maximum occurs. And in this case, x is the price of a bagel in dollars. So a bagel costs 55 cents. And this would be $300. Now let's see what it's asking me. Letter A says, what is the maximum profit the bakery makes? Well, the maximum profit is $300. At what price must the bakery sell the bagels to maximize their profit? Well, that would be 55 cents. And that's the answer to that second one. So that really wasn't that difficult at all when it's already given in vertex form. The next one is not given in vertex form. A rock club's profit from booking local bands depends on the ticket price. Using past receipts, the owners find that the profit can be modeled by the function that's given there, where T represents the ticket price in dollars. A, what price yields the maximum profit? B, what is the maximum profit? So we're looking for the vertex of this function. P equals, group the quadratic and linear term together with parentheses. Next, next divide by negative 15. Negative 15 times t squared. Is that 40? Let me check to make sure. It's going to be negative 40. Yes. So t squared minus 40t plus 50. C is going to be negative 40 divided by 2, which is negative 20. Square that, that's 400. Add that inside the parentheses. Negative 15 times t squared minus 40t plus 400 plus 50. Multiply the number on the outside with the number we just added inside. And you're welcome to use a calculator here. 15 times 400, is that 6,000? Yes. So it's actually negative 15. Negative 15 times 400 is negative 6,000. And how do I balance that? I subtracted 6,000, so I add 6,000 here. So P, or profit, is going to equal negative 15 times the quantity t minus 20 squared plus 6,050. Vertex is 20, 6,050. Remember, this is your maximum. This is where or when your maximum occurs. Let's go answer the questions. What price yields the maximum profit? That would be $20 per ticket. So that's the price that yields the maximum profit. What is the maximum profit? $6,050 is the maximum profit. So we could have found that by doing x equals negative b over 2a, and it might be just as fast to do that, but now you know two ways that you could find those answers to a and b. I believe this is our last one, maybe. We'll see in just a moment. Suppose you throw a ball straight up from the ground with a velocity of 80 feet per second. As the ball moves upward, gravity slows it. Eventually, the ball begins to fall back to the ground. The height of the ball after t seconds in the air is given by that quadratic function. Let's put it in vertex form. So this is great practice to all those notes that we just did. Negative 16. I'm going to go ahead and factor that out and put t squared minus 5t, I do believe. I'm going to find that constant. C is going to be negative 5 divided by 2, square that, 25/4. So I'm going to add 25/4 inside the parentheses. T squared, oops, hold on, let me undo. T squared minus 5t plus 25/4, and I don't have a constant outside there. Factor. Oops, no, don't factor yet. I almost forgot, didn't I? Multiply negative 16 with 25/4. I think we did that earlier, negative 16 times 25/4. Pretty sure we did. Oops, I'm still highlighting. And that was negative 400 over 4, which is a negative 100. So we subtracted 100. To balance it, we add 100. So h of t is going to equal negative 16 times the quantity t minus 5/2 squared plus 100. Now in this case, 5/2 is still time, so I am going to rewrite that as negative 16 times t minus 2.5 squared plus 100. And my vertex is 2.5 and positive 100. How high does the ball go? So maximum height, 100, I'm assuming feet. Yes, feet per second it says. So 100 feet. For how many seconds is the ball in the air before it hits the ground? So straight up from the ground, how long is the ball in the air? So the ball's in the air from here all the way to here. Is the answer 2.5? No, because after 2.5 seconds, it's reached its maximum height of 100 feet. So it's still in the air until here when it hits the ground, so 5 seconds. That's how long the ball is in the air. Moving on to the next example. And we're finished with all those, yay. When we did Student Journal page 58, which was page 72 in our notebook, I did say that we would do 1, 2, and 3 with week 17. So here it is. I know it's the last part of this video, and who knows how long this video is because I can't see the total time. I do want to mention that I made a mistake in the original video with number 4. And I hope that when you watch these videos, you remember that I'm a human and I make silly, silly mistakes sometimes, and I believe number 4 is one where I made a silly mistake. When I was finding C on number 4, I did negative 14 divided by 2. I think this is the one. And then I think I made it 7 over 2, which is completely wrong. You get negative 7. And then when you square negative 7, you get 49. So I should have rewritten it as y squared minus 14y plus 49 and factored that as y minus 7 squared. And of course, it also asks me to find that value of c. So c is actually 49. Those should have been the two answers. I'm pretty sure that's the one that I missed. But don't be afraid to correct me. I absolutely do make mistakes, as we all do. None of us are perfect, and we make mistakes. And so don't ever be afraid to say, hey, Miss Bibb, I think you messed up here, because you're probably right when you say that. Okay, now let's solve these couple of problems. The reason why I wanted to wait to solve them is I wanted to make sure you understood what it meant to be to have a perfect square trinomial. Number 1, number 2, number 3, they are already perfect square trinomials. Now, if you wanted to subtract 2 from both sides on number 1 and then subtract 2 again so that you could make it equal the constant so you could complete the square, you're welcome to do that. But I want you to recognize that each of these are already perfect square trinomials. This is a perfect square trinomial. This is a perfect square trinomial. How do I know? For number 1, take your b value, divide it by 2, and square it, and you get 4. For number 2, take your b value, divide it by 2, and square it, you get 4. Now, number 3 is a little tricky to be able to see that that's a perfect square trinomial, because you can't take your 6 and divide it by 2 and square it. You've got this 9 here. But hopefully, after some inspection and thought, you see that that left side would actually factor into 3w plus 1, that quantity squared. So think about it for a minute. That really will factor into that problem. So all of these are perfect square trinomials. X squared plus 4x plus 4, that's a perfect square trinomial. It factors into x plus 2, the quantity squared. Number 2, t squared minus 40t plus 400 factors into t minus 20, that quantity squared. And now all you have to do to solve is take the square root. You can solve by using square roots like it says in the problem. So x plus 2 is going to equal plus or minus the square root of 2. Subtract 2 from both sides. X will equal negative 2 plus or minus the square root of 2. For number 2, I'm going to take the square root of both sides. T minus 20 is going to equal plus or minus the square root of 300. Has a perfect square in it. That's 100. So the square root of 100 times the square root of 3. T minus 20 is going to equal plus or minus 10 times the square root of 3. Add 20 to both sides. T is going to equal 20 plus or minus 10 times the square root of 3. And one more, take the square root of both sides. 3w plus 1 is going to equal plus or minus the square root of negative 1 times the square root of 9 times the square root of 2. So 3w plus 1 is going to equal plus or minus 3i times the square root of 2. Subtract 1 first. 3w will equal negative 1 plus or minus 3i square root of 2. Divide both sides by 3. W will equal negative 1 plus or minus 3i times the square root of 2 over 3. Or if you want to write it as W equals negative 1/3 plus or minus I times the square root of 2, you're welcome to do that. The reason why that works is because 3 and 3 would reduce to 1. Now, over here, negative 1 and 3 will not reduce anything except negative 1/3. And I do believe that's it. Let's go see. There's your week 17 assignment, week 18 and 19, and then your checklist. So hopefully you have learned quite a bit from these notes that we've done. And if you need any help, please reach out. Have a wonderful day.